So we have seen problems on speed and distance, and we have seen separate problems on percentage. Now let's combine both of it and see a problem. So the problem states that Sarita drives a car at 30 kilometers per hour and reaches the office 8 minutes late. Had she driven 25% faster, she would have been able to reach 8 minutes earlier than the scheduled time. How far is the office? Okay, first you can see that the question represents the distance in the form of kilometers and time in the form of minutes. So let's convert this. 30 kilometers per hour can be written as 30 kilometers because the answer is in the form of kilometer, but the question has data in the form of minutes, so 60 minutes. Now if the question has data in the form of seconds, you have to convert accordingly. So this will give 0.5 kilometers per minute. So this is the speed. Now the question states that she reaches the office 8 minutes late, and in the second case she reaches the office 8 minutes earlier than the scheduled time. So we have to find a way to represent the scheduled time. Scheduled time can be represented as x. Now scheduled time is something which is constant because in both the cases it takes a certain amount of time, and she is 8 minutes late in the first case and then 8 minutes earlier. So the fixed amount of time is called as x. Okay, now let's represent the two cases. We have case 1 where she reaches the office 8 minutes late, and case 2 where she reaches the office 8 minutes early. Now the time taken for case 1 is x plus 8 because she takes 8 extra minutes. Time taken for case 2 is x minus 8. The speed in case 1 is 0.5. So we can find distance, which is x plus 8 into 0.5 because she takes 0.5 kilometers per minute. And case 2, we don't know the speed yet. We only know in the form of percentage. So let's first find out the speed in case 2. So the question states that she takes 25% more speed than the first case. So that will be 125% of the initial speed, which is 0.5. 125% of this gives 0.625. You can calculate this easily. 100% is 0.5. 25% will be 0.125. Then 125% will be 0.625. So now we have the speed and the time. So we can find out the distance easily. Distance will be given as 0.625 into the time taken, which is x minus 8. Because so this is the time taken. Okay, now we have the speed, time and the distance in both the cases. Now what is the constant factor in both of these cases? The constant factor will be the distance, because the distance from a home to the office will be the same in both the cases. The time varies, the speed varies, but not the distance. So we can equate both of these equations. We have, in one case we have x plus 8 into 0.5, and the other case we have x minus 8 into 0.625. So let's equate x minus 8 into 0.625. Now it's easy. We just have to solve this equation to find the value of x. We have 0.5 into x plus 8 into 0.5, which gives you 4. And then we have 0.625 into x minus 8 into 0.625, which is actually 5. Now to further solve this, we get 9 on this side, and this will be 0.625 minus 0.5x, which is 0.125x. You can find x by taking x is equal to 9 by 0.125, and this will give you 72. Okay, now we have found out the value of x. X is equal to 72. But what are they asking in the question? They have not asked the value of x, but they've asked the value of the distance between her office and home. So it takes 72 minutes. 72 minutes is a scheduled time, and it takes 8 extra minutes to reach in 0.5 kilometers per minute. Or it takes 8 less minutes if she's going at a speed of 6 to 5 kilometers per minute. So we can use either of these data. We can use this one or this one to find the distance. It's going to be the same answer. So let's use this case. We have 80 minutes, 72 plus 8 into 0.5 kilometers per minute. Now this will give you the distance, which is 40 kilometers. So this is the answer. Just tell me if you need more problems on speed and distance. I'll make some. Thank you.